Hey everybody, hope you're doing well today. All right, so here's the plan. We are going to talk about the artsiest thing Mrs. Fry can do, which is graph. All right, specifically, we're going to talk about graphing exponential functions. Well, they're equations, which are in fact functions. So first, let's get a couple of nuts and bolts things out of the way. The main thing you should be aware of is that this equation right here, f of x equals a times b to the x, is going to be our definition of the exponential function. And to be quite honest, I am going to say it should be everybody's definition of the exponential function. People like to zhuzh this up a little bit and make it fancy and all that other stuff. It doesn't need to be, okay? The gist is we are taking, y equals, right, an output. A, that means something, that we know at the start, an initial amount. We're multiplying it by whatever our base is, and we're taking it to some exponent, right? We've got a base, and we have our exponent. And we don't know what that is because, often it's like time, which is like constantly changing, so that's why it's a variable. So anyway, there are a few key rules that we need to just keep in mind in order to make this function actually be exponential. The first rule is that a could be any value. It just can't be 0. Let's talk about that for a second. Why can't a be 0? That's not actually one of our questions down here, but let's just think about this. What is 0 times b to the x? Well, that would be just 0, and that's boring, and we don't want to look at that because that's not interesting. And then the other thing that has to be true is that b is some positive number, different from 1. And that's what I'm going to talk about in more detail. Why this restriction on b? Well, first off, so the restriction on b is that it needs to be positive. To show you why, I'm actually going to talk about the situations if b wasn't positive. So let's just say we had y equals a times b to the x, and b was negative, okay? So, I don't know, I'll make up a number. Let's say it was, we're just going to use -2. That's easy to do in our head. Let's start to make a table of values for if y equals -2 to the x. Well, x, y. Okay, so let's say I put in 0. Okay, remember that gets me out 1. Let's say I put in 1. Okay, -2 to the first is -2. Let's say I put in 2. Okay, that's positive. Let's say I put in 3. That'd be back to negative. And then I put in 4, that'd be positive again. Okay, so hopefully you're seeing this pattern where we'd be at like -2, and then we'd be up at 4, and then we'd be down at -8, and then we'd be up at 16. And this sort of weird oscillating situation isn't exponential. Okay, it doesn't model what actually happens in situations that grow exponentially. And that's because alternating the growth would grow and it would decay, and it would grow and it would decay, and we can't have both of those things. So can't have negative. That's just no good. Doesn't work out. Okay. And then what would happen if y equals a times b to the x had a b value that was 1? Well, okay, let's just write that out. Y equals a, so whatever, we make a times 1 to the x. Well, here's the situation. Forget about the a value. 1 to the x? Okay. X, y. If I plug in 1, that's 1. If I plug in 2, that's 1. If I plug in 3, that's 1. 4 is 1. 5 is 1. Infinity is 1. Because 1 to anything is 1. This is boring. More importantly, it doesn't do what exponential functions do. They grow and they decay. This is just flat. I mean, it's just like at 1. Okay, so this situation is like growth and decay, like it can't make up its mind. Okay, so we can't have that. And then this one is flat. It is neither growing nor decaying. So it's not doing anything that we relate to an exponential function. So explain why or find an example. It needs to be positive. The b value needs to be positive to allow for growth or decay. To give you a real world example, when things grow or things decay, it relates to the whole idea of like adding or subtracting from 100%, right? You're adding or subtracting, you know, not from 100, you know, you're starting out with 100%, that's like 1, and then you're adding or subtracting some rate. Well, if you subtract over 100% and you're negative, that's not possible. You can't lose more than you had. Okay, you could certainly double or triple, that's possible, but you can't lose everything. So that's why the negative situation. And then the 1 is just flat, it's just boring. Okay, so hopefully that helped give you an idea of the actual, what an exponential function is and kind of why we have some of these rules about that base. Okay, so just as a recap, b, so y equals a times b to the x. This is our basic function. We've got our initial value. We've got our base, which is positive. I'll write that out so you don't think that's some weird positive. And greater than 0. And not 1. Okay, those are the rules about the base. Okay, and then our exponent's whatever we want it to be. So that's the gist of our exponential function. Now we're going to look at what that actually does in graph form. Yay! Okay, have fun.